It's 3 a.m. You're lying in bed, and it feels like someone is smashing your big toe with a sledgehammer. Every heartbeat sends a fresh wave of pain. It's not a fracture, not an injury. It's a gout attack. And more than 55 million people worldwide know exactly what that feels like. For centuries, we've fought this so-called disease of kings with medieval tools. Painkillers that strain the liver, anti-inflammatory drugs that stress the kidneys, diet restrictions that turn every meal into a minefield. But here's the hard truth. None of these treatments remove the root cause. They mask the pain while uric acid crystals continue grinding away inside your joints. Today, I'm going to show you something that sounds like science fiction, but is now scientific reality. A research team at Southern Medical University in China, with an average age of just 26, has created something unprecedented. Microscopic robots that autonomously patrol your body and precisely destroy uric acid crystals. Animal trials have already succeeded. Human clinical trials are projected within 5 years. Welcome to the age of nanomedicine. Why current gout treatments are fundamentally limited. First, let's get something straight. Gout isn't just about eating too much red meat or drinking beer. It's a metabolic disorder. Your body either produces too much uric acid or fails to excrete enough of it. When levels get too high, sharp, needle-like crystals form inside your joints, most commonly the big toe, but also knees, ankles, and wrists. Here's the real problem. Your immune system sees those crystals as invaders and launches an attack. That inflammatory response is what causes the swelling, redness, and excruciating pain. But when you take colchicine or febuxostat, the crystals don't disappear. They stay there, silently damaging cartilage and setting up the next attack. Current treatments are defensive. Allopurinol reduces uric acid production. NSAIDs reduce inflammation. Neither removes existing crystals. Neither repairs joint damage. Long-term use? You're looking at kidney risks, liver toxicity, cardiovascular concerns. You're trading tomorrow's health for today's relief. That's the paradox of modern gout therapy. We can manage it, but we can't cure it. Until now. The breakthrough: self-propelled nanomotors. In April 2025, a team led by Professor Tu Yingfeng at Southern Medical University published a study in Nature Communications that could completely reshape how we treat metabolic disease. They didn't develop a new drug. They built a machine. Imagine a particle so small that 70,000 of them lined up side by side equal the width of a single human hair. Now imagine that particle is a precision-engineered robot with 3 components: an engine, a therapeutic payload, a protective shell. This is the world's first silica-based nanomotor designed specifically for active gout therapy. And here's why that matters. Traditional nanoparticles are passive. After injection, they drift randomly, hoping to bump into their target. These nanomotors hunt. How they work. The secret lies in something called an asymmetric pore structure. Think of a microscopic rocket nozzle. The nanomotor's silica shell contains 8 nanometer pores, about 1,000th the width of a human hair, engineered in a non-symmetrical configuration. Here's the brilliant part. When the nanomotor encounters uric acid, it uses it as fuel. Inside the motor is uricase, an enzyme that breaks uric acid down into allantoin, a harmless, water-soluble compound that the body can easily eliminate. That reaction creates an ion gradient, generating microscopic propulsion. In other words, the disease powers its own destruction. These nanomotors move 3 times faster than passive nanoparticles. And they don't wander randomly. In lab tests, their contact efficiency with uric acid crystals was 5 times higher than conventional particles. They swarm and surround the crystals almost like coordinated bees attacking a target. The result? In animal studies, joint damage repair exceeded 90%. Not 50%, not 70%. Over 90%. The protective system, built for the human body. You might be thinking, that works in a petri dish. But what about inside the body? Exactly. The human body is hostile to enzymes, temperature changes, pH fluctuations, proteases that break down foreign proteins. Here's where the engineering gets impressive. The team encapsulated uricase inside a hollow mesoporous silica shell, essentially giving it armor. Surface amino modifications anchor the enzyme while still allowing uric acid molecules to enter. The data is striking. Enzyme resistance to proteases improved 2 5-fold. Even at 70 degrees Celsius, hot enough to denature most proteins, the enzyme retained 46% activity. In the relatively stable environment of a joint, that translates to prolonged therapeutic action. But they solved another hidden issue. When uricase breaks down uric acid, it produces hydrogen peroxide. Yes, the same compound used to disinfect wounds. In joints, hydrogen peroxide causes oxidative stress and inflammation. So the nanomotor carries a second payload, sodium citrate. This compound catalyzes the breakdown of hydrogen peroxide into water and oxygen harmless byproducts. The released oxygen even helps alkalize the joint environment. Which brings us to the final piece. Gouty joints are acidic. Normal synovial fluid sits around pH 7.4. Gout can drop it to 6.8 or lower. Acidity promotes crystal formation, creating a vicious cycle. These nanomotors maintain joint pH between 7.5 and 7.8 for up to 72 hours. That environment prevents new crystal formation. This isn't symptom control. It's biochemical reprogramming. The evidence. In acute gout rat models, joint swelling was significantly reduced. Differences appeared within 6 hours. Effects persisted at 24 hours. Statistical significance, P is less than 0.001. Joint damage repair exceeded 90%. No liver toxicity. No kidney damage. No additional joint irritation. In a field where standard drugs carry black box warnings, that's extraordinary. Joint pH remained stable in the therapeutic range for 3 full days, addressing one of the biggest clinical challenges in gout, recurrence. The team behind it. Let's pause for a second. The research team's average age? 26. In an era where we hear about aging research pipelines and shrinking innovation, a group of 20-somethings solved a problem that has plagued medicine for centuries. They spent 3 years refining pore size, optimizing surface chemistry, and rebuilding after failed iterations. When early sodium citrate loading caused uneven distribution and pH crashes, they didn't publish half-finished data. They went back to the lab. That's real science. Their inspiration? Bee swarm coordination. They asked, what if nanoparticles could coordinate like a hive? Now they can. Old versus new. A category shift. Let's compare. Allopurinol, lifelong systemic suppression, no crystal removal. Colchicine, narrow therapeutic window. GI toxicity. NSAIDs, pain relief with cardiovascular and renal risks. Pegloticase, enzyme therapy, but systemic. IV infusion, high cost, immune reactions. Nanomotors, local injection into the affected joint. Minimal systemic exposure. Active crystal hunting, tissue repair. Self-propelled using disease chemistry. This isn't incremental improvement. It's a category shift. From chemical management to mechanical intervention, from passive therapy to active targeting, from chronic suppression to potential cure. What comes next? Let's stay grounded. This technology has completed animal trials. Human trials have not yet begun. A 5-year clinical translation timeline is ambitious but plausible. The vision? A single injection during an acute flare. You walk into a clinic in severe pain. You walk out with microscopic machines clearing your joint over the next 72 hours. No daily pills. No lifelong organ stress. Just repair. And this platform may extend beyond gout, potentially targeting diabetes, atherosclerosis, and other metabolic diseases. This could mark the beginning of active nanomedicine. Why this matters? Gout has been documented since ancient Egypt. Hippocrates wrote about it. It affected Henry VIII and Benjamin Franklin. For thousands of years, we've treated it with plant extracts, colchicine, diet restriction, and pain control. In 2025, a group of young scientists looked at this ancient disease and asked, what if we stopped fighting symptoms and started deploying machines? They built those machines. And they work. This isn't just about gout. It's about programmable matter. Engineering solutions inside biology. Precision interventions instead of systemic compromise. For 55 million people worldwide, this represents something rare in medicine. Real hope. The robots are coming. And this time, they're on our side. Call to action. If you found this breakthrough as fascinating as I did, hit subscribe. We're tracking the most important medical technology advances, and you won't want to miss updates when human trials begin. Drop a comment below. Would you volunteer for a nanorobot joint injection clinical trial? Let's talk about the ethics, risks, and future of active nanomedicine. And as always, if you're dealing with gout or any medical condition, talk to your doctor. This video is for educational purposes only, not medical advice. Stay informed, stay hopeful, stay curious. If you want more updates on China's latest tech moves and the unique way China views its own technology, please like and subscribe.